Hello, physics students. Welcome back to Mr. Boyd Goes Over Your Graded Assignments. Now we'll work on the potential energy graded assignments. When I look at this, we're going to do questions 1, 2, 3, and 4 in this video. Question 5 with its multiple parts and difficulty, we'll have a completely separate video. So again, we'll go through those. So here we go with question number 1 on the potential energy graded assignment. So as we look at this again, potential energy, specifically gravitational potential energy, is mass, gravity, and height. The only tricky part on this one is the fact that there's a person on a platform and it's the total gravitational potential energy. So with this, with GPE, gravitational potential energy, mass, gravity, and height, you just have to add the masses together. So you would have a 71 kilogram plus 300 kilograms times the 9.81 meters per second squared times the height, in this case, it is 58 meters above the ground. Okay, and then don't forget that your unit is joules. All right, question number 2. You have a known mass and you have a known height or distance that it's traveled, and we want to know the potential energy. So then it's just about gravity being involved, so that GPE, again, mg, and h. So with that, we have the mass, 6.4 kilograms, times 9.81 meters per second squared, times the height of 2.1 meters. Okay, and then it's just a straight out multiplication from there. All right, question number 3. Okay, we have the mass of the rocket. Okay, it is fired vertically. Okay, and it's giving us the amount of kinetic energy before it leaves the pad. Okay, so with this, okay, the fuel itself, okay, gives the ability to have this. So in this value that they're giving us, okay, this kind of energy that would be potential, when we look at this, we know that the situation when we get to how high, if we're taking this into account and we know the KE ahead of time, and that we can use this idea that KE value, which is a full thing given, we don't need to write it out, would equal M, G, and H. And with that, we can divide by M and G. Okay, now we can't factor this out because we're given the kinetic energy as a full quantity, so we're going to leave that alone. So then we're basically left with the idea that the height is our kinetic energy value divided by mass times gravity. Okay, so with that, we have 1,960 joules of energy, okay, which will be divided by, okay, the 10 kilograms, okay, times our 9.81 meters per second squared, and then that would end up giving us our height in meters. Okay. All right. Question 4 has a little left over from where we were when I went over the preview of everything. So with this, we are looking for the potential energy of the car at the top of the hill. Okay, and remember that this is the length of the ramp that the car went up, or the hill that the car went up. So in terms of work, this is all we did was the height, and we have a 22-degree incline there. So with this, we can modify our equation a little bit to say that our gravitational potential energy is mass times gravity times our height, or our distance in this case, okay? Our distance times sine of the angle, because we have this angle and we're looking for the opposite. The d sine of the angle replaces the height. Okay, so then I'm going to drop down because of my image. Okay, I have 8,500 kilograms times 9.81 meters per second squared times my ramp or hill height or length, 825 meters times sine of my angle here, which is 22 degrees. Make sure your calculator is in degree mode when you do this, and that should give you your answer in joules. I put it in scientific notation because it's such a large number. Okay, So like I said, that is questions 1 through 4. Question 5, we're going to treat separately. If I can get outside with a camera, I'm going to go ahead and give you an example of this, if we can be able to look at this. If not, I might have to try and do something on the inside. Try and film it and give you a visual of this. All right? Again, if you have questions on any of these potential energy or the kinetic energy equations that we've already done, just shoot me an email or fill out the form and let me know. If not, I'll see you here in a little bit with question number 5.